For this exponent rule law, it's something where it's not really easy to pin down. This is exactly where you're going to use it. It's just use it all the time. It just goes all the time. Sometimes you're rolling the exponent down, sometimes you're rolling the exponent up, and I'll show you an example of both. Say you got log base 2 of 4 to the power of 6. I don't want to figure out what 4 to the power of 6 is, so I can just roll this down and work it out. This is the same as 6 times log base 2 of 4. Log base 2 of 4 is just 2, so this is 6 times 2, which is 12. So there's a nice little use of rolling the exponent down. If we're trying to simplify and write things as a single log, though, anytime you have a coefficient in front of the log, you need to roll it up. For example, 2 log x plus 3 log y, I can't combine those because they're not like terms. But we can roll up the powers and see what happens. So this 2 log x plus 3 log y is the same as log x squared plus log y cubed. Now I can use the product rule. So with the numbers in front, I couldn't say that this is log xy. But once I have them rolled up, then I know this is the same as the log of x squared times y cubed. Something to point out, and it's really important that you recognize this, is that the log base 2 of 2 all to the power of 3 is not the same as the log base 2 of 2 to the power of 3. These are two different things. Log base 2 of 2 is 1, so that log base 2 of 2 all to the power of 3 is really just 1 to the power of 3, which is 1. Log base 2 of 2 to the power of 3, well, we know when those bases are the same, we can cancel them out. So this just equals 3. So it's always important, I haven't pointed this out yet, but it's really important to recognize this difference. That all these rules, when there's an exponent, it's always assumed that the exponent is on the base that's inside of the log.